All right. So as I promised, last circuit. This will model the last one you have on the homework. Obviously, the numbers will be different, but the circuit design is the same. So we have to start in the same place. We have to get the total resistance, which looks like it's going to be a little more complicated than it was last time. And yeah, because it is. But don't fret too much. It's not that bad. This is 4. That one's 3. That one's 7, 40, and 8. Okay. So if I just think about current coming from the battery, that current has no choice but to go through R1 before it splits. And on the return, it's going to go through R5. So V, R1, and R5 have the same current. Now let's think about 2 and 3. Any current that passes through 2, it has no other choice but to pass through 3. So R2 and R3 are series to each other. If I think about the gravity diagram, here's 0, here's 120. Everyone's going down ladder number 1. But then we have a choice, ladder 2 or ladder 4. Okay, right? I choose to go to 2 or I choose to go to 4. Now, if I choose to go to 2, I don't have a choice. I'm going to 3. Regardless, though, everyone's going down 5. 1, 2, 3, 4, 5. The act of going through R2 forces you to go through R3. So what I'm going to do right away is view this circuit as 4, 10, 40, and 8. I'm just going to combine 2 and 3. Why not? And now it looks an awful lot like the ones you were doing earlier. So let's go ahead and combine this stuff here. 1 over 10 plus 1 over 40 is 1 over R. Calculator time, 1 over 10 plus 1 over 40. All right. 0.125 is 1 over R. R is 8. So the circuit's now like 4, 8, 8, or a total of 20. Questions? Okay. So 20. That means this is 6. 120 equals I times 20. I is 6. The resistors, 6 amps. All 6 amps has to go through R1. There is no other option. All 6 amps had to have come from R5. Six by 4, 24. 6 by 8, 48. R1 burns 24. R5 burns 48. The power source adds 120. So this line, 120 volts. This line, 0 volts. All right. What about this line? Well, it had 120 volts and burned 24 down to 96. What happens after? I don't know. I don't know what's on this line. A little too much. Okay. What about this line? Well, I do know whatever I have immediately after R4, it's the same thing I have immediately after R3. And it's the same thing I have immediately before R5. So it's got to be 48. 48 volts on one side, we burn 48, we're left with 0. Make sense? You walk into a store with $48 in cash. You walk out, no cash, and a receipt that says $48 spent. How much money did you spend? 48. What do you have left? 0. What about credit cards? Get out. Don't complicate it. All right. So we take a look. 96 volts before, 48 volts after. All right. That means this fellow here, it burned 48 volts. Did I do that math right? Yeah. So what about these ones? That's tricky. Let's keep going on R4 since I got, the voltage and the resistance. I know the current will be 1.2. In the previous examples, I always zoomed in at this junction here to show you how the current was behaving, and I did it because of this. What does this one have to be? 6 came in, 1.2 kept going straight. How many turned right? Hmm. 4.8 amps. 4.8. 4.8. Hey, we know something very big. This will show you. Am I doing it right? Am I doing it right? I got 96 volts right before R2. I got 48 volts right after R3. These two things combined better wipe out 48 volts. Because, come on. When we look at the gravity perspective, you choose ladder 4, you drop 48. All right. I don't know how much I'm dropping here. I don't know how much I'm dropping here. But what I do know is the two combined better be 48. Let's make sure that it is. 4.8 times 3. That's 14.4. 4.8 times 7. That's 33.6. Oh, by golly. 14.4 plus 33.6. 48. It's like magic, except it's not because it's real. 24 by 6. 144. 14.4 by 4.8. That's 69.1. 33.6 by 4.8. 161. 48 by 1.2. That's 57.6. 48 by 6. That's 288. 120 by 6. That's 720. Did we do it? 144 plus 69.1 plus 161 plus 57.6 plus 288. I got 719.7. Yeah, I'm comfortable saying that something got lost in rounding. I'm happy. You should be happy too.